Hello, everyone. Brian Gockel here, Weather Service Office of Observations, and we wanted to welcome you to the Satellite Book Club Seminar Series number 236. Today's presentation is leveraging satellite data for mesoanalysis during severe weather operations. Our presenter today is Dr. Keith Sherburn from the NWS AFS Analyze Forecast and Support Office. Our facilitator today is Chris Smith, GOES-R Satellite Liaison to OPC and WPC. Just a few announcements before we get underway. Sessions being recorded, as you may have heard the chime. Per OCIO Privacy Act guidelines, attendees will not have the ability to use their microphones or webcams. Please see the pinned messages in the chat for more info. As usual, Q&A session will be at the end of the presentation. We encourage you to remain on the line and please post your questions in the chat room because we'll field them from there. If you're logged in under an alias account, please sign in with your full name or specify your full name when asking a question in the chat. We are looking for future presenters, as always, trying to get the schedule filled out for the summer. So please do, if you're interested, contact the KRS team if you would like to present or facilitate. And there's a form in the chat, which makes it very easy to do that. Please contact Ross Van Til if you need any help creating training or finding or creating training materials that either might not be available or if you can't locate them. Ross can help you out there. Thanks as always to Ross and the OCLO, the GEO and the LEO programs, and our facilitator and speaker today. A few words about Keith before we get underway. Dr. Keith Sherburn serves as the Severe Weather Program Coordinator through the NWS AFS Analyzed Forecast and Support Office. Keith joined the Severe program in January after 7 years as a meteorologist in WFO Rapid City. While in Rapid City, he was an active contributor to the Central Region Convective Warning Improvement Project and facilitator of the Remote Mesoanalyst Mutual Aid Program, the latter of which he continues in his new role. Leveraging his passion for research to operations and operations to research initiatives, collaboration and mutual aid, Keith helps execute the Severe program's milestones and shapes its vision in the agency's transition to the new operations ops model. Keith received his BS in meteorology from the University of Oklahoma and obtained an MS and a Ph.D. from North Carolina State University. Hey, Keith, welcome to the Satellite Book Club.
Hey, thanks, Brian. Appreciate it. All right, let's go ahead and get started here. Thanks, everybody, for joining. Thank you to Emily for the invites and to the entire team who makes these a success. Always really pleased with the Satellite Book Club presentation, so I'm privileged to be presenting here today. And I will say, I'll just start by saying the scheduling of the Satellite Book Clubs has really worked out over the last couple of weeks. Those who were able to attend last week had the privilege of hearing an overview of the Remote Mesoanalysis Mutual Aid, or RMA program, from Randy Graham and Jenny Pittman. And this presentation really jumps off from that foundation and focuses on applications of satellite data for mesoanalysis during severe weather operations. So I'll go ahead and jump right in with an example. This is a sandwich loop, so we have visible and IR imagery from a recent event in which I helped facilitate the RMA mutual aid. And I want to start by just asking, what can we identify here? And I'll give you a few seconds here to kind of take everything in, get a sense of what's being shown in the loop here. But going forward, what we can see, so let me see if I can annotate on the screen here. Got, well, right here, you got a boundary that's going to be the dry line in place there. Off to the west in Nebraska, you can see the cold front, which is starting to push more rapidly southward, south central Nebraska and in north central Kansas. Obviously, you have some areas of convection, one up northern Iowa, extending up into Minnesota. There, that's a little bit more mature convection, but you can still see some embedded overshooting tops there, so still some pretty strong updrafts. Down to the south, you have more recent CI in northeastern Kansas, maybe above Anvil cirrus plume there, but again, some pretty pronounced overshooting tops right along the dry line there. What's happening up in Iowa, eastern Iowa into Illinois there? So Initially, early in the loop, you see some horizontal convective rolls, starting to see those diminish. So you're losing daytime heating, you're losing the mixing there, so maybe not quite as unstable. In the boundary layer, ahead of the dry line, but right along the dry line, you're continuing to see some weak cumuliform convection there. Farther east, across eastern Iowa, you got maybe more stratiform indications that more stable boundary layer in place out there if any storms were to get going. But basically not expecting any convective initiation across central or eastern Iowa. And then farther east from Illinois down to central Missouri or so, looks like you have more in the way of ACUS or mid-level convection, maybe atop that stable boundary layer. So basically you can see a lot, right, in just one loop of visible and infrared imagery. You got boundaries, you have relatively unstable and stable boundary layers, you can get the characteristics of ongoing convection, and where you may be more or less likely to see convective initiation in the next, say, hour or two. So a lot that you can pick out just from a single loop there. So with that initial exercise in mind, I just want to provide a quick outline for a talk. To be pretty brief here, but we're going to be focusing on RMA mutual aid applications, and you can refer to last week's book club presentation for more details on that program. And I'm first going to just dive into a few cases where I served as primary facilitator, December 10th, 2021, December 9th, 2023, and then a more recent case, March 14th, 2025. And then I'll just touch on a few more examples from a variety of RMA facilitators to hit on some key points. So let's get started with some examples from December 10th, 2021. This was a notable cool season long track supercell tornado event. There was also a QLCS that impacted areas including St. Louis, but that long track supercell tornado event was across Kentucky, and this event featured the infamous Mayfield tornado. As an aside, I saw Dan McKeamy hop on earlier before we got started. I communicated with him quite a bit when he was still in Louisville during this event, so he probably remembers it quite well. But so this first example here, I want to start with the essence of mesoanalysis in severe weather operations, and I consider that to be just merging diagnostic and prognostic analysis. So basically diagnose what's happening and try to make a forecast of what's going to be happening next. So in this case, just a couple of VisIR sandwich images about an hour apart. So at right, we have 1931 UTC, and at left, 2031 UTC. And in the area dashed here, what you can identify is just a general area of cooling cloud tops. It's not necessarily convective, but there's a hint here that you have a broad area of just general large scale ascent. So I note in the chat here that there was some mid-level mesoscale ascent over the last hour across northeastern Oklahoma, and this zone will shift into northwestern Arkansas and southwestern Missouri over the next hour or two. So again, identifying what's going on right now, what we can identify via satellite, and then what implications that could have going forward. And here I'm pointing out a few features that could play a role in convective development and evolution in the short term. So this is a little bit later on from that initial post that I made in chat. So taking each of these in turn. Okay, starting with the green here. Obviously here you have a little bit more cumuliform cloud structure. You have some CI, a little bit of lightning there as well. It's tough to see on the screen here, but there is a little bit of lightning activity. That's the initial convection for the day. So as of right now, that's the place to be looking for any subsequent strengthening of the ongoing convection. A little bit off to the west in the yellow, we see that there's some developing horizontal convective rolls in the vicinity of the ascent that I mentioned in that previous post. So here you're seeing the boundary layer could be destabilizing a little bit. So you have both that larger scale support for ascent and the boundary layer destabilization starting to overlap. So that could be an area that you watch for CI in the not too distant future. In the blue here have more in the way of altocumulus. So you have unstable mid-level air, but you haven't quite destabilized at the surface yet. Nonetheless, it shows that the profile is conducive for pretty strong updrafts if you can get that boundary layer to destabilize. And then the red, the farthest east, that's showing a potential cross-hatching of billow clouds. Billow clouds do tend to indicate areas where it's a little bit more stable, but when you have crosshatching like that, it's indicative of pretty strong low-level shear or strong SRH. So this could be an environment to watch if you get any CI to the west that starts to move into that area. If you start to see more cumuliform structure to the clouds, that could be an indication that you're getting an overlap of really strong shear with strong instability. Now, one thing I like to emphasize in the mesoanalysis process is how varying triggers can influence storm environments. And in particular, we focus a lot on the role of advection and conditioning in the destabilization process, but less on how large-scale ascent could potentially impact the thermodynamic profile. So whenever I have a chance, I raise the topic of potential instability and how its release can rapidly lead to increases in CAPE. This is especially pertinent in cool season cases with marginal instability. This was a cool season case. There was pretty decent instability. But I did want to point out here, we have, again, these horizontal convective rolls. So you have some boundary layer instability here. You have some stable billow clouds not far south of there. But ultimately, as that better forcing arrived from the west, it could be that you start to get enough lift essentially to eliminate the cap in that point. And that's what I think you're starting to see already there in northwestern Missouri. And it could become a little bit more widespread as the better forcing arrived. And ultimately, that is what we ended up seeing in this event. So following on from that discussion of the approaching large-scale ascent, here I highlight general moistening and ascent trends region-wide based on the mid-level water vapor imagery. I really like using water vapor imagery to just get a sense of where the larger scale ascent or descent may be in a given situation. So here you can see several pockets of enhanced moisture that's largely associated with convection. But just in general, there's a trend towards a little bit more moistening, a little bit more sign of ascent across the entire region. And you could see the better line of forcing moving in from the west as well there. So this is just a good example of something that you can identify with water vapor imagery to get a sense of the larger scale trends as an event is unfolding. A little bit later, I do get somewhat speculative, but I try to tie together several of the points that I've mentioned so far during the event, and you can kind of keep track of the time here. So we're now after 0Z with the earlier image on the right. But we see general strengthening of the ongoing convection. So if you look from northeastern Arkansas here down towards southwestern Arkansas, maybe even getting into Texas and Oklahoma, and compare that from 0021 to 0051, there's pretty rapid development and intensification of some of these supercells already at that point. So we see general strengthening of that ongoing convection. That could mean that the larger scale ascent is overcoming some of the earlier subsidence. But I then posit that perhaps this mid-level subsidence that we're starting to see right here could actually augment CAPE in this situation, right? So how could that subsidence here actually impact subsequent storms and their associated environment? So we focus a lot here on this localized descent in this particular case. Now, tying together, again, some of these points that I've been mentioning so far, obviously from the previous satellite imagery, the convection here has expanded quite a bit, strengthened quite a bit in this situation. And I mentioned, again, it's plausible that mid-level subsidence may have actually transitioned to potential instability given the sufficiently moist low levels in this case. Again, as I noted, this is speculative, but when possible, I think that RMA is also a really great venue for merging that theory, the research, and operations all together to collectively enhance our understanding of some of the processes that might be contributing to what we're observing. And I will say overall, I've learned much more through the RMA process than I've ever contributed, and I think a lot of the facilitators would probably agree with that point. All right, turning to the next event, a couple of years later on December 9th, 2023, this was a notable event again across Middle Tennessee and Central Kentucky, had tornadoes impacting the Nashville and Clarksville areas, and RMA support was really focused on that Middle Tennessee, Western Tennessee, and Southern Kentucky area. So I just have a couple of slides for this event. And first off, looking at water vapor, I'm honing in on a couple of different features here. So we have this broad area of enhanced moistening and ascent over eastern Missouri and Illinois. It's lifting northeastward away from the area of interest. Again, we're focusing kind of on Middle Tennessee up through South Central Kentucky here. So it's possible that additional CI upstream may be somewhat limited because you're losing that support, larger scale support for ascent. Right now, though, if you look near Little Rock, a little bit south of Little Rock, you do have an ongoing supercell. You have a couple of supercells as well off to the east. Had some hints at CI a little bit south of Little Rock, but overall, most of these supercells are standing pretty well alone. They're fairly discrete, don't have a lot affecting their inflow environment at the moment. A little later, downstream of that supercell in Arkansas, we do start to see a distinct change in cloud character across Western Tennessee. So earlier in the day, in the morning hours, you had somewhat of a laminar structure across most of the area. And on the western edge of this, you're starting to see cloud cover becoming increasingly cumuliform as we head into the afternoon. So what's that mean? That means the boundary layer is starting to destabilize. So the inflow environment for this supercell or all of these storms that are approaching from the west is ultimately going to be fed by an unstable boundary layer. And ultimately, this supercell is one of those that brought large hail and tornadoes to Middle Tennessee. So this seemingly subtle transition in cloud character here really does tell us a lot about what the future could hold for ongoing storms. And last up was a more recent case. This was March 14th, 2025. Just featured a moderate risk from the Storm Prediction Center. And this was really an all hands on deck kind of day for the RMA program. We had several of those in March and early April where we had a lot of facilitators on hand. We had multiple support rooms in place as well as we had maybe about a dozen offices on this day requesting support. So large scale severe weather outbreaks always tend to stretch thin some of the mutual aid programs that we have out there. And starting off, this is a guest appearance from John Stopcotty. He's the SU over in North Platte. He used a 4-panel satellite image here combined with SBC Mesoanalysis data to identify the leading edge of ascent there in the yellow oval, which was associated with an approaching mid-level vorticity maximum that could help promote CI later in the event. And you can see the vort max here in the SBC Mesoanalysis fields as well. And this raises a key point, which we're going to see in another example later as well. And that's that the full potential of satellite data, or really any analysis, observation, model forecast, whatever you're using, it's reached only when combined with other sources of information. So nothing is optimal on its own. And employing a synthesis of as much information as possible is really how we can best diagnose current conditions and make an informed prediction. So going back to that key of mesoanalysis, going from the diagnosis to the prediction. So getting into a few loops from this case, first off, via water vapor, obviously we can identify the center of the parent low at this point, pretty nice area of cyclonic circulation evident over the Midwest. And here I combine water vapor imagery with GLM flash extent density, which gives us both a sense of the large scale features and can help us identify some of the more impressive updrafts within a broader system. So you see the updrafts here getting into eastern Missouri, really starting to pick up in terms of lightning activity at this particular time. And in addition to that increased lightning activity, we do start to see some pronounced ascent here and just moistening back behind the supercells as well. So that's why I say in the chat here that the storms don't appear to be going away anytime soon because we are getting some signals of broader large-scale support for ascent as well in the vicinity of that convection. In this case, I'm combining IR and GLM total optical energy, noting that that latter can sometimes be helpful in detecting deviant motion in ongoing or developing storms. But the more unique point here is that via infrared imagery, despite being post-sunset, we can still identify some areas of horizontal convective rolls. Here in the Missouri boot heel, there's some of those horizontal convective rolls that are a little bit tough to see because it's just a subtle change in the grays there in the infrared imagery. But there's some there. There's some additional horizontal convective rolls down through central Arkansas as well. And this indicates that the boundary layer is still unstable and pretty well mixed, despite being post-sunset, which could support storm maintenance as the convection from the west moves into those areas. I have another infrared loop here. This one's interesting because you can clearly see the cirrus shield from convection across western parts of the image impinging on previously developing convection over western and middle Tennessee. So see that increase in convective strength here, the cirrus plume, basically the reds in infrared imagery, accelerating out towards the east here. And right at the leading edge of that cirrus plume, you're getting some very clear subsidence. So you go from your reds to blues and purples very rapidly in that general corridor there. And it's hard to get the exact right time on the loop to annotate it. But you also see that there were some fairly strong storms down in middle Tennessee. So there's one right here, there's another right there. Those weaken very rapidly as that cirrus shield and the compensating subsidence moves into the area. So ultimately, based on this, I would expect that you're going to have limited CI, if any, further convective initiation ahead of this line of storms as you head into the night. All right, just a few more other examples here to wrap up, and then I'll leave some time for Q&A. So this is a great post from Andrew Quigley, packed with a lot of tidbits. At left, he's utilizing infrared imagery to help illustrate areas with the most robust updrafts at present. So you can see some overshooting tops here in the western part of the area, southwest of Boonville. But he then combines this imagery with several different SBC mesoanalysis fields. And these are particularly relevant to QLCS mesovortex and tornado production. So looking especially at 0.3 kilometer cape, 0.3 kilometer shear, and low-level lapse rates to get a sense of what low-level instability and low-level shear happens to be in this particular case. So he's using this synthesis, this combined approach, to identify the areas most likely to produce a tornado in the near term and highlighting that for the offices of need. And that's in the red hatched contour that he has here. I love this example. It really synthesizes key observational and environmental analysis components to inform potential warning and messaging decisions. So this is one of my favorite, more recent examples from the RMA chat room. Great stuff there. Here's a case from another event, and here I'm really just leveraging low-level water vapor imagery to point out one consideration of the thermodynamic environment, and that is the scope of steep mid-level lapse rates, low-level lapse rates actually in this case, because this is low-level water vapor imagery. And that's really everywhere you're seeing kind of the yellows and oranges, especially out here ahead of the ongoing convection. That's just representative of steep lapse rates in the low to mid levels. So basically another way of identifying what the environment has in store for the storms that are moving into that area. And I'd also say this was a good opportunity to point out an apparent lightning jump for a storm in central Kentucky. There are a couple storms there with really high lightning rates, but this one in particular started to perk up right around that time that I grabbed the loop. And this last example is from a more recent event across central Nebraska. This was early in the event, and Katie McGee, who was the facilitator for this case, took the opportunity to leverage cloud day phase RGB imagery and analyze the potential location of a differential heating boundary that could serve as a source of vorticity for that existing supercell off to the west. So the supercell was here. Potential boundary is in the white dashed lines here, but you can see a clear distinction of more of the cumulus cloud structure off to the west, closer to the supercell itself, and more of this laminar, almost billow cloud type structure off to the east. So very distinct shift in boundary layer instability there. As an aside, this was a really unique case that Katie and John Stopcotty, who was working the event, presented at a webinar series that Randy Bowers, who's the severe program lead, has recently spun up called Meso Mondays. And I just want to make a brief pitch for those, because these are unrecorded, they're informal or conversational webinars, and really offer a great opportunity to just geek out about severe weather and mesoanalysis and learn. So if you're interested in attending or presenting at one of those, just reach out to me or Randy for some more info on that. But those are a great opportunity to to shoot the breeze with fellow severe weather nerds. So highly recommended there. So that's about all I have. We can head over to the Q&A after that. But to close, I just want to emphasize the importance of mesoanalysis in severe weather operations. Most of us here likely agree with that assessment, but if not, I'd contend that critical mesoanalysis improves our warnings, our messaging, and really all of the severe weather related services that we provide. So I'm hopeful that this presentation and last week's presentation help reinforce that. I also want to advocate for mutual aid across the board when it comes to NWS operations. Teamwork makes us all more effective at what we do. And given the incredible amount of data that we're all trying to digest and synthesize in operations, an extra set of eyes is always helpful. I know that none of us are right all of the time, but all of us could be right most of the time. And mutual aid just generally is the future of NWS operations if we want to make the most of the tools that we have. But getting back to satellite, satellite in particular is a powerful tool for assessing crucial environmental factors, potential sources of large-scale ascent or descent, and characteristics of storm evolution. But I want to emphasize that last point too, is like any of the tools available to us, it's most useful when you combine it with other data, such as surface obs, radar analyses, high-res model output, such as the WFOs. All of those tools used together, I think, will point us in the right direction most of the time. Anyway, that's all I have. I'll turn it over to Chris for facilitation, and looking forward to Q&A.
All right, thank you, Keith, for a great presentation. A lot of neat satellite imagery there for mesoanalyses. And I'll encourage attendees to please stay on for discussion now, including field forecast offices and regional headquarters. I encourage everyone to change their meeting layout to tiled and select hide tiles without video. You can submit questions in the chat, and in a week from today, we're going to keep some of these mesoanalyses going. I think I saw Katie McGee in a slide there. We'll have on Thursday, May 22nd at noon Eastern, Katie McGee, Becca Darish, and Chris White from the WFO in Huntsville discussing navigating the operational impacts of a rapidly changing environment. This will go over the May 8th through 9th, 2024 tornado outbreak from beginning to end. Sounds like an interesting book club next week. And I encourage attendees to contact the Tower S team, Kashad Bowman and Emily Maddox, for questions about the Satellite Book Club or configuration of satellite products. So I'll start here. We already have a few questions in the chat for you, Keith. I'm going to start with Bill Sherburn, asking if you've considered using satellite soundings, and I'm guessing new caps, for example, to track changes in instability between 12Z and 0Z upper air soundings.
That's a great idea. It's not something that I do a lot in the RMA process. What I do try to leverage a lot are ACARS soundings when they're available. That's a source of information that we leverage quite a bit in terms of the RMA facilitators, but we don't use the new cap soundings as much. Is there a web-based source for those? I'm honestly not sure. I know we have it some in AWIPS, but often a lot of the facilitators may be helping out from home and may not have access to AWIPS. So if there is a web-based source for those, I'd be happy to use that.
I'll wait for someone to chime in there. I think there are some gridded and other output from OSPO, but maybe someone else in the chat will have. Okay, Bill Schoberg says yes, so maybe he'll have a link that he can provide us for some help there. The next question comes from Dan Lindsay. Nice presentation, Keith. What's your take on the relative advantage, if any, of the 1-minute mesosector versus 5-minute CONUS imagery available for this type of mesoanalysis?
Yeah, the higher temporal resolution, the better, I would say. So when it's available to us, you might be able to capture, especially things like rapidly developing updrafts, right? If you have explosive growth, you may be able to pick out, say, the overshooting tops a little bit more rapidly, or get a sense of when a storm, like a supercell, is becoming a little bit more consistent in terms of its updraft structure versus pulsy. So I try to leverage the 1-minute data as much as possible. I think some of the features you're going to be able to pick out either way, but time is always of the essence when especially when you're straddling that mesoanalysis to warning scale type of analysis. You want to use the best available data possible. So yeah, when it's available, I like to use the 1-minute meso data. Good question, Dan.
Great, thank you, Keith. And we have Jason Apke. Does AFSO have or coordinate any testbed opportunities to evaluate new and emerging satellite products for this type of mesoanalysis?
So we don't coordinate any of that at AFS. I'd be curious to learn more about different opportunities that there are. So I would follow up with the same question. I think to anyone who may have knowledge of that, if there are any test beds that the severe program could help out with, or be guinea pigs to test some things out, I'd be happy to do that on our end. I know Randy would too.
Yes,
Okay.
we have a lot of people putting in the chat. The satellite convective applications experiment is ongoing. That is a test bed where we're looking at satellite products. Jason Apke is the developer there for the Octane product. To look at convection and convective initiation. There will be reports out and there's blogs. I can put a blog link in there if you'd like to see some of the experimental products that are being evaluated there, or Kevin can if he's on the call. He's the testbed facilitator there.
Yeah, I would love to. Sorry to interrupt you there.
No.
Randy and I are each participating in the SFE, but we haven't been as involved in the other hazardous weather testbed experiments. So that'd be great. I'd really enjoy doing that. Awesome. Yeah, thanks, Kevin.
Yeah, and you can see some of the blogs there. Week 1 was last week, so you'll have a lot of content there to look over. It looks like Joseph put in the link for the new cap soundings from OSPO, so there's your web-based link, so you don't have to only rely on AWIPS. And I'll get to another question, and people can keep submitting in the chat. So what satellite products do you reference most frequently when conducting mesoanalysis?
Yeah, as shown by the examples there, I tend to favor the sandwich product quite a bit, especially during the daylight hours. I think it just gives you it gives you the texture that you get with visible, but also the context that infrared provides in terms of ascent and descent. So that's one of my go-tos, but I think a lot of the products can be especially useful. I like using all of the different levels of water vapor as well to point out different features, like mid-level to upper-level water vapor is good for just large-scale support for ascent or descent. Low-level could be advantageous when you're looking at factors such as lapse rates and so forth. There's a lot of great stuff out there. I'd be curious to hear what other folks use a lot as well. If anyone wants to chime in and chat, if there are particular satellite-based products that you like to use a lot in the mesoanalysis process, I'd be curious to hear that.
Yeah, I'll just say as a satellite liaison for the Weather Prediction Center, we have a MetWatch desk that does mesoscale precipitation discussions for flash flooding. I know Lightning Cast has been a popular product there for detecting convective initiation for regimes like the monsoon. So I have that story, but we can have others chime in the chat from WFOs. And do you have any additional satellite-derived tools that you think would be beneficial for the purpose of mesoanalysis?
So one thing that would be really beneficial, and maybe this is already in development or being tested, is if there would be a way to, and maybe this is done maybe via like prob severe or prob lightning or something, but if there would be a way to track objects and determine like growth rate, cooling rate. I think it is done with prob severe objects a little bit, but if there was a plan view way of viewing that, so you track objects and identify like the cooling rate based on infrared imagery or something like that to get a sense of how rapidly updrafts are developing. Oh, that's what Octane does. Excellent.
Yeah,
All
I was
right,
about
perfect.
to say, it looks like we need to connect you with Jason because his product is an optical flow product and tracks cloud top cooling and divergence. So it sounds like something that would cater right to your needs, which is great. And you'll see some of examples in those blogs from the hazardous weather test bed. It looks like in the chat, there's day cloud phase is a popular one. I know that's popular here as well as the sandwich, and even experimenting some day cloud phase with channel 13 IR imagery to make a sandwich. I'd be interested in seeing that in AWIPS. And then one more question is, what do you think is the biggest challenge for mesoanalyses? Are certain convective regimes, have more of a challenge than others? Do you have any intel on that?
Yeah. Well, I'd be curious to hear from the other facilitators on this too, because we've all experienced different events, I think, in which we've been helping to facilitate, and we all work in different parts of the country too, so we see our local events. I think some of the ones that are most difficult are those that are strictly like overnight cases, because you're a little bit more limited in the different satellite products you can use, and just in general. I think some of the observations and model analyses that may be available to you. So those cool season cases where it's really dependent on how much advection are you going to get, or how much destabilization you're going to be able to manage via the release of potential instability, when that is the limiting factor. Like how far north are you going to get just enough instability to get severe weather? I think those are the ones that are the trickiest for me, and just ones that are, horribly mixed mode and really messy organization. The case that I mentioned that Katie and John were working together on, it started as like a lone supercell, but man, there was a lot of complex storm interactions that led to some interesting polygonology and stuff in that particular case. So there's definitely a spectrum of relatively straightforward to very challenging, and each event is a little bit different in that regard.
Great answer, thank you. I'll hang on for another minute to see if there's any other questions, but looking forward to keeping this theme next week with the Huntsville presentation, and it looks like maybe some RMA potential over the next several days. We're entering a busy stretch of severe weather, it seems. So we'll see if anything else pops in the chat. Otherwise, thank you, Keith, and I will turn it back to Brian, and we'll conclude today's presentation.
All right. Thank you, Chris Smith, for facilitating today's session. And thanks, Keith, for that, bringing us those 3 convective cases that they were very instructive, to say the least. As Chris mentioned, please join us a week from today when Katie, Becca, and Chris from WFO Huntsville will walk us through a convective tornadic case from May 8th, 9th, 2024. So see you in a week. Thanks for joining. Take care.